Okay. So now we are going to be looking at these problems where we need to simplify. But most importantly, just remember to take a screenshot. Then from there, try to work out these problems and see how far you can go. It's just 4 problems that you need to try. And then once you've worked them out, you can play the video so that you will see as we do the corrections. So that means what you can do now, it is just to take a screenshot. Let me just zoom it in so that it is clear. Take a screenshot and then pause the video and start working on these as a live test. And then from there, once you are done, you play the video and then we compare our final answers. So let's see. Without wasting much of our precious time, I will therefore start with that first one. So remember, honorable member, do not waste your time by rewriting the words of the question. Just say, okay, it is 4.2 where I am, and then 4.2.1 is exactly what I'm going to be doing. And that problem, it is inside the brackets, x, y squared. You close that to the exponent of 3, and you divide it by x to the 3, and then you have y to the 4. This is exactly what you are having. So remember, in mathematics, we always start where we are having the brackets. But in this case, it looks like we will have to apply our knowledge of the laws of exponents. So let's see. Here you are having 1. You are having x to the exponent of 1. That is exactly what you are having there. That 1, it is there, but as an invisible 1. So now that means you will therefore multiply that outside exponent by that, and you will also multiply that outside exponent by that. You therefore end up having x to the exponent of 1 times 3, which is 3, and then you are having y to the exponent of 2 times 3, which is 6. And this is dividing. You already have x to the exponent of 3, then you have y to the exponent of 4. So you are allowed to already cancel these two because they are exactly the same. But if you want to show them canceling mathematically by using the laws of exponents, that means you have that x to the exponent of 3, that one at the top. Nay, you take this one at the bottom. You know that when you are dividing the same basis, you subtract their exponents. And then again, this y at the top, which is to the exponent of 6, you will therefore minus that 4, because it is that 4 at the bottom, and when it goes to the top, it changes the sign, it becomes a minus. So you see now you end up having x. What is 3 minus 3? Definitely that is 0. And then you are having y. What is 6 minus 4? That is 2. Remember, anything to the exponent of 0 is 1. So it's like you are having 1y squared. And that 1, it will be there as invisible 1. And you end up having just y to the exponent of 2. That's how it ends, the honorable member. That's how you work it out. And that's how it ends. Okay, then it's fine. What else? It looks like all that you have to do now, it is to give yourself a mark if you got your final answer to be exactly that. It just has to be exactly that. Okay, then it's fine. What else, or where are we? Let's see. So now we've got to jump onto the next question. I'll just have to remove all of this. I think I'll just have to remove all of these. I hope that made sense. So sometimes I do all these extra calculations so that it makes sense to you in terms of why the x to the 3 disappears, so that you've got a sense and understanding of what happens when it disappears. Then we are on this one. Okay, it looks like it's a lengthy problem that we're going to be dealing with on that one, but it's fine. So now let's see, what are you going to have? It will be negative 12 a squared, a squared b to the 3, that you plus it by 8a to the 3b squared, that you plus it by 6, and then you're having a squared b to the 4, the whole of that, you divide it by 2a squared b squared. This is the question that you are having. So where are you going to start? So this is what happens, honorable member. You need to check how many terms are you having at the top. It's 1, 2, 3, because the term is separated by a sign of a plus or a minus. So that means at the top you've got 3 terms. What about at the bottom? It is just 1 term. So the whole of this is a term, because in between you do not have a plus or a minus. That is the only thing that separates a term. So the most important thing is for you to realize that, okay, in each term at the top, what is it that is common? In terms of the numbers, definitely the 12 can be broken down into 2 numbers. For example, 12, it can be 2 times 6. 8, it can be 2 times 4. That 6, it can be 2 times 3, something like that. And then you also have a squared, you have the a's there, you have the a's there. So that means the a's, they do appear in all the terms. What about b? There is b there, and there. B, it also appears in all the terms. So now it is fine. So what exactly are we going to do? So that means we can just, for example, say the 12, it is the same as that negative 2, that you multiply it by 6. And then in terms of the a's, we do have a squared. And then in terms of the b's, you can still say, okay, it is b squared multiplying the third b. The reason why I'm doing it this way is because I'm already noticing that I can take out a squared here, a squared there, a squared there. It is common. And then in terms of the b, I can only take a maximum of 2. So b squared, b squared, b squared. That is why the b's, I'm therefore separating it. Instead of writing it as b to the 3, I can separate it like that. And then for the second term, it is the same as 2 times 4. And then in terms of the a's, I will separate it to make it a squared times a. Why? Because I know that I'm going to have to take out that a squared. Same on this side. C is the same as 2 times 3, that is 6. In terms of the a, you do have it as a squared, and then the b can have b squared, b squared. Because b squared and b squared, it takes you back to that b to the exponent of 4. So now I'm having 2a squared, b squared. So now let's start to take out the common factors. I believe you will agree with me when I say, you see that 2 can be taken out as a common factor because it is there, it is there, it is there. Nah. What else? the a squared, because it is there, it is there, it is there. So that means I can also take out that a squared to the outside. What about b? I will take it as b squared because it's there. Wait, okay, it looks like I made a mistake there. It was supposed to be a squared there, and that b, I will take it out as b squared, and I will also take out 1b squared there. So that means I will have b squared as well. So now that I've taken them out, what remains? It will be negative 6b. That is what will remain, because that has been taken out, taken out, taken out. So I'll remain with that negative, that b, and that 6. That's what I did there. And then there I will remain with positive 4a. Yes, positive 4a, because the 2 is taken out as a common factor, a squared, and then b squared. So I'm just remaining with that 4a. Yes. And then there I will say 2 taken out, b squared taken out, b squared taken out. It looks like I'm just remaining with that positive 3 and the other b squared. Yes, looks like that's what I'm remaining with there. And the whole of that is being divided by 2a squared b squared. Okay, then the nice part is that now I can cancel. It looks like the whole of that can cancel with the whole of that. And as they cancel, what you remain with, it is just that negative 6b plus 4a plus 3b squared. Yes. This seems to be the end of it. This definitely seems to be the end of it. And you cannot add the like terms there because there are no like terms. There you are having 6p, it's like to the exponent of invisible 1. That one is clear because it's not the same letter as a. And then there, even though you are having the b, but this one is to the exponent of 2. That's why you can't work it out without one of that. So that means if you got your final answer to be exactly this, then you give yourself a mark on that one. And that is exactly how you would work it out. I hope that makes sense. So now I'm just going to remove all 4. Jump onto a different question there. Okay, I will just have to remove all of that. Remove. Okay, let's see. So now we are on 4.2.3, 4.3.1. So we are now starting with something completely different. Okay, so here again you simplify. How do you know that you're supposed to simplify? It's because you do not have an equal sign. And the problem that you are simplifying in this case, I'll rewrite it, is that negative 2a into a minus that being d, that you plus it by 2d in the brackets, you are having 2a y minus 3d. Yes. Let's double check if that question has been copied correctly. You are having negative 2a into a minus d close plus 2d into 2a minus 3D. Okay, then it's fine. What else are we having there? So you see now, you are definitely going to have to do that by that, so that you remove those brackets. That's exactly what you are going to do there. But you need to be very careful here. Let's see how. Because you are having that -2 that multiplies the A. It's -2A that multiplies the A. This becomes -2, but A is two of them. So when you multiply the same letters, depending on the number of the letters, you just add it at the top. It's not like you will say 3A's. Nope. But you write it at the top. And then here you are having -2A that you multiplied by -D. So that means you will therefore have plus 2, then AD. Alphabetically, A comes first. That's why you say A and then D next. But remember, in terms of the signs, you are having a negative multiplying a negative, which makes it a positive. Okay, and then you are having that 2 that you multiplied with that 2, it ends up being +4. Alphabetically, A comes first, and then you write D after, even though you are multiplying the 2D by the 2A. Just follow the alphabetical order. And then what else? You are having the 3 that multiplies with that 2, definitely becomes a -6. And then because it is the D's that you are multiplying, you therefore write it as D squared. Name. Be very, very careful on that part in terms of whatever that you multiply, and make sure that if it is the same letters, you just add it in the position of the exponent. So now we can try and look for the like terms if they exist. Let's see. It looks like that one of a number A squared, it doesn't have a like term. And that one of D squared, it doesn't have a like terms, but you do have this one of AD and that one of AD. So that means you can work out those two, but the others, they just remain as they are because they don't have their like terms to work with. So that means here, it's like you're having 2AD and 4AD. Will it not be 6AD? It definitely has to be 6AD. And then anything else, you just rewrite it exactly as it is. And that should be the end of it. That should be the end of it. Based on my interpretation there, it looks like that should be the end of it. Yes. Yes. Yes, yes. Okay. Then it's fine. You can just give yourself a mark for that one, only if it is exactly like that. So now let's jump on to this last problem and see how far you can go with this one. I'm just going to remove all of that. Okay, then it's fine. What else am I going to do? Think I will therefore have to rewrite that question, which is 6A, that you plus it by 12B, and you divide the whole of that by 2, and you plus it by 4A, that is being added to 16, that is B, the whole of that is divided by 2. Yes. Okay. Then it's fine, the honorable member. Just remember that you've got many ways in which you can work out this thing. Maybe you can say, let me first focus on the numerators and see if there is something that can be taken out as a common factor there. Remember, the common factor can be taken out as a number or as a letter, or it could be both. So now let's see. According to me, it looks like 2 can be taken out as a common factor there, because that thing at the top is the same as 2 times 3a plus 2 times, is it 4 to make it that, not that. It has to be 6, yes. 6, and then you are having b, whole of that being divided by 2. And then on this side, you can still say I'm having 2 times 2a plus 16, I think is 2 times 8, b, the whole of that being divided by 2. Can you see? So now why not take out the 2 as a common factor? It exists there and there. So that means you can therefore say, okay, I'm having 2 inside, I'm remaining with 3a plus 6b. Yes, that's what you remain with after taking out the 2. Here, you can still take out the 2. Yes, you'll remain with 2a plus 8b. Yes, and then that is being divided by 2. Look at how nice this is. The 2 that you took out as a common factor cancels with that. What is it that you remain with? You will definitely remain with just that 3a plus 6b. Then on that other side, again, the 2 cancels with that. And what do you remain with? You remain with just plus 2a plus 8b. Can you see what happened there? Then that's when you ask yourself to say, okay, based on these things that are remaining, can I not somehow, what is it? Can I not somehow find the like terms that I can work with? Perhaps we can, because you look at that and that, you realize that those 2 can be added together. Can they not be added together to become what? 5a's. Yes. And that one and that one of the b, what will it be? That to the, will it not be 14b? I think it has to be 14b. Yes. Something of that nature, the honorable member. And now we can say, yes, this thing, it is now simplified. It is in its simplest form. So that's how the honorable member, you can think about things that require simplification. So I think that was the last one, and you can just give yourself a mark there in case if you got it to be exactly that. Okay, then it's fine. It looks like I will just have to leave it here